We'll start. Okay. We'll start with the chemical reactions and equations, chemistry, first chapter. Okay. So we will study about what is chemical reactions and how. What do you mean by chemical equations? How to write that? Okay, and what are the different types of chemical equations we have, and why do we get different types of chemical equations, and how to balance the equation? All these we try to study. Okay, so chemistry starts from here, and like when you start studying chemistry, it will be easier even for the 11th. Okay. Chemical reactions and equations. So what do you mean by chemical reactions? Whenever there is a change, chemical change, then we call it as a chemical reaction. Whenever there is a chemical change, then we call it as a chemical reaction. For example, when hydrogen combines with the oxygen, when hydrogen combines with the oxygen, you will get water. Okay, so here these are called as the reactants. They are called as the reactants, and the water is the product. These are the reactants and this is the product. So this is a chemical reaction in which water is produced. Okay, and water is produced. So hydrogen and oxygen, they are gases, correct? Hydrogen and gases. Hydrogen is a gas, oxygen is a gas, but water, it's a liquid. But water is a liquid. So in a chemical reaction, there can be change in the physical state. There can be change in the state of the product, and the properties of the product, many times it will be completely different than the reactants. Many times it is completely different than the reactants. Okay, and here what happens, the hydrogen bonds with the oxygen, it combines with the oxygen, and it will be formed as the water. Okay, and you would have heard, right? For example, you have water plus sugar. Okay, you will get sugar solution, correct? So here there is a difference. This is a chemical reaction, but this is not a chemical reaction actually. Okay, how you can make out whether it's a chemical reaction or not? Because the composition of the that will not change here. The composition will not change here. Here what happens, only the sugar will become very small particles, and they in between the intermolecular spaces in the water, the sugar will be dissociated, or it will be there in the intermolecular spaces in the water. That's it. But it will not combine with the water then. Whereas hydrogen plus oxygen, they to combine to form a new product, water. Okay, a new product. And in chemical reaction, how a bond is formed? Just we'll give little bit introduction, then we will go. Okay, how a bond is formed? How bond is formed here?
Then combining two atoms, combining two particles. Electrons.
Only in a chemical reaction, actually, only the electrons, either one will take the electrons or the other will receive the electrons, or it will share the electrons. The electrons, that is the outermost electrons, they are called as the valence electrons, these are the one which is responsible for the chemical reaction. Okay, again I repeat, see, in the outermost orbit, the electrons will be there. They are the one which will take part in the chemical reaction. Because of that, a bond is formed, and hence there is the chemical reaction. Okay, so atoms, they will not combining, they don't combine. That means only the electrons, they interchange. Okay, they can move from one atom to the other atom, or it will be shared like that. Hmm? And the protons will not be included, or it is not the one which will take part in the chemical reaction. Protons will never take part in the chemical reaction. Whenever there is a break in the nucleus, what happens? It becomes the, you would have studied about the nuclear reactions, right? So it will become a nuclear reaction. Only the electrons will take part in the chemical reactions. Which electrons? The valence electrons are the one which will take part in the chemical reaction. Okay, they are the one which will take part in the chemical reactions. This is about the chemical reactions. And few examples here. Food is cooked. What is that? It's a chemical change. There will be a chemical change, correct? In that. Food gets digested in our body. That is also a chemical change, where because of the some chemical reactions happening in the body. Okay. Now we'll see about what are the changes can happen in a chemical reactions. What are the chemical changes can happen in a chemical reaction? First is the change in the state. That is, the reactants can be in one state and the product can be in the other state. For example, water plus oxygen. Here, water, hydrogen plus oxygen, you will get water. Hydrogen plus oxygen, you will get water. Here, hydrogen and oxygen, they are the gases, but water is a product which is a liquid. Okay, which is a liquid. So there is change in state in this reaction. Next is the change in color. Yeah, the reactants can be in the colorless, or it may have some color, but there can be change in the color in the product. Okay, there can be change in the color in the product. So one of the example for that, that is change in color, is copper sulfate plus the iron, you will get FeSO4, ferrous sulfate plus the copper. Okay, this is an example where there is change in the color. Copper sulfate is blue in color. It is blue in color. When it reacts with the iron, you will get ferrous sulfate solution, which is a pale green in color, plus the copper. Okay, here the solution color will change from blue to pale green color. So this is one example where there is change in the color. Next comes the evolution of a gas. So the reactants may not be a gas. Okay. So but in the product there may be an evolution of a gas. Okay. There may be an evolution of a glass. Example, okay, evolution of a gas. Zinc plus H2SO4, you will get ZnSO4 plus H2. Okay. Here, zinc is a solid, H2SO4 is aqueous in nature, that is dissolved in the water. Okay. Then you will get zinc sulfate plus the hydrogen gas. Here, hydrogen gas is evolved. Here the hydrogen gas is evolved. Here in the reactants we don't have a gas, but in the product we have got, there is an evolution of a gas. So this is one example where there can be an evolution of a gas. Okay, next one, change in temperature. Change in temperature. Okay, so their change in a temperature means whenever there is a reaction, there can be either increase in the temperature or decrease in the temperature. There can be increase in the temperature or decrease in the temperature. So, increase in the temperature. There are many reactions where there is increase in the temperature. For example, if you consider many reactions which involve the acid, which has the reactants as the acid, many times there will be increase in the temperature. Okay, and some reactions are there where there will be decrease in the temperature. So these are the changes what we can see in while there is a chemical reaction. What we can see when there is a chemical reactions. So what are the changes that can occur? So the changes that can occur in the chemical reactions. The first one, it is the change in the state. Change in the state. So, in a chemical reactions, the reactants and the product can be in the different state. Example, hydrogen plus the oxygen, you will get water. So, which is a liquid. So, next is a change in the color. In a chemical reactions, so there can be change in the color, change in the color of the product of the product. Example, copper sulfate plus iron, you will get ferrous sulfate plus the copper. This is a aqueous solution, this is a solid, and this is also aqueous solution, and this is solid. So copper sulfate is blue in color, this is pale green in color, pale green in color. Pale green, you can see. Pale green in color. Okay. What do you mean by aqueous solution? Ah. So copper sulfate crystals will be there, right? That when dissolved in water, we call it as an aqueous solution. Okay, we call it as an aqueous solution. Solution of the gas. Okay. solution of a gas. In a chemical reaction, zinc plus H2SO4, you will get zinc sulfate plus the hydrogen gas. Then you have change in temperature, change in the temperature. In a chemical reaction, there can be increase in the temperature, increase in the temperature, or decrease in the temperature due to the reaction, due to the reaction. So example, if you consider CaO, calcium oxide, we call it as aqueous. Quicklime plus the water, you will get calcium hydroxide, which is aqueous, plus heat is produced. Write down the reaction which increases the temperature is called exothermic reaction. It is called as an exothermic reaction. Okay. So there are like two types of reaction. One is exothermic reaction, other is the endothermic reaction. Exothermic reaction means where the temperature will be increased. There we call it as an exothermic reaction. Here also, this is a quick line. We also call it as quick line calcium oxide that combines with the water. When you combine that with the water, you will get calcium hydroxide, which is aqueous in nature. That is, calcium hydroxide will be dissolved in the water there, plus heat is produced. Okay. We studied like chemical equations. We are trying to write about the chemical equations, right? So what do you mean by a chemical equation? So chemical equation means like what are the reactants? We try to state what are the reactants that will combine to form the product, and we try to use the molecular formula here. Okay, using the symbols, we try to use the molecular formula to represent that. For example, in a chemical equation, magnesium combines with the oxygen to form magnesium oxide. Magnesium oxide. Okay, so this is what? This is magnesium. So symbol of magnesium is Mg, and this is oxygen. So magnesium plus oxygen, you will get magnesium oxide, right? So we use the, instead of the word equation, we try to use the its molecular formula, its symbols to write the equation. So that we call it as a chemical equations. And chemical equations are very important in the chemistry. You have to write equations. Okay. Then only like it is will be scoring. So here, magnesium plus the oxygen. Magnesium combines with the oxygen to form the magnesium oxide. I have written here MgO, right? Why I can't write it as Mg2O also I can write, right? Hmm? Or I can write it as MgO2. Many places it will be there, right? Why I can't do write this?
So that the equation stays
Not only balance, not the balance. Here, actually it is not balanced here. Two oxygen here, one oxygen here, right?
2 mg plus O2 is equals to 2 mgO. Get to balance.
Not for balancing. It is like about the valency, how it combines. That means these two are wrong actually, correct? So MgO is the correct formula for magnesium oxide. How you consider that? That means one magnesium combines with one oxygen. That is the meaning here. One magnesium combines with one oxygen. So how many atoms combines with how many other atom? How you will know? By the valency. Most of them know, I think. Do you know everyone? How to write? See, magnesium valency is 2. Okay. Oxygen valency is 2. Hmm? So cross multiply here. That means 2 magnesium combines with 2 oxygen atoms to form the magnesium oxide. 2 combines with 2 or 1 combines with the 1. Correct? No? That's how you will get the magnesium oxide. So what is its valency? Valency means the how many electrons which will take part in the chemical reaction. That is called as the valency. Okay? Write down that valency, the number of electrons, the number of electrons which take part in the chemical reaction is called its valency. Okay, so usually the magnesium, the 2 electrons will take part. In the magnesium, 2 electrons will take part. Oxygen also 2. So 2 magnesium here. So 2 magnesium electrons take part and oxygen also 2 electrons. That is why it is like 2 magnesium electrons will take part with 2 oxygen. That means 2 magnesium atoms combines with 2 oxygen atoms to form the magnesium oxide. Or in the other way to tell, you can write like this also, correct? Or you can also write it as 1 magnesium combines with 1 oxygen, correct? So you can write like this. Other day I will tell how like that when valency will come and all, I will tell on the other day. First you just know these things. Okay. So understood now? Valency you have to by heart. What are the valencies of magnesium, oxygen, every element, how many you are using here, you have to by heart. Then by cross multiplication, you can know what will be the formula for that. Okay. Hmm? So here in the book they have given magnesium ribbon burns in the air, correct? So what will happen when magnesium ribbon burns in air?
flame and it forms
Magnesium
white powder.
white powder. Then what else after the white powder? What else they have given? Dazzling white color you can see. Okay. So magnesium when combines with the air. They have told that a magnesium remain burning in the air. What do you mean by burning in the air? Oxygen. Whenever they say that burning in the air means it is combining with the oxygen. When heat is, you're providing the heat, then it will combine with the oxygen present in the air. Okay, so magnesium plus oxygen, you will get it as magnesium oxide. And magnesium oxide, it is a white powder. So it is white in color and it is a solid. Okay. So these things very important. White powder, all these it is required. During in the exam, they ask all these questions. So now we'll study about the balanced chemical equation. That is how to balance a chemical equation. How to balance a chemical equation. Now what equation I have written here, that is magnesium plus the oxygen, you will get magnesium oxide, correct? So whether it is balanced, is it balanced? No, because here magnesium, in the reactant you have one magnesium, two oxygen, correct? But here you have one magnesium, one oxygen. Here two atoms are there, but here one. So you have to balance the chemical equation. How we can balance this?
Adding 2 to energy on the reactant and adding 2 on the energy.
So how to balance a chemical equation? So Mg O2 will get Mg. Here in the reactant oxygen is more. So increase here. What we have to do, you have to increase the product. So you will make it as 2 Mg. So here magnesium you have 2 and oxygen 2. 2 oxygen is balanced, but magnesium, so you have to put 2 here. So this is a balanced chemical equation. Okay. Next we'll try to balance the other equation. Write down this Fe plus H2O, you will get Fe3O4 plus the H2. Here iron, here you have 3, but in the reactant it is only 1. So we try to balance this equation. So once you listen here, reactants, what and all you have? Iron, hydrogen and oxygen. And in the product, you have, you should have the same elements only, no? Because whatever you have to put, that only will react. So here also iron, hydrogen and oxygen. Iron, you have 1 here, 2 hydrogen and 1 oxygen. Always you have to balance such a way that first you have to balance the other elements. Okay. At the end, you have to balance the oxygen and hydrogen. Here you have 3, this is 4 and this is 2. Iron, you have only 1 here, you have 3. So I have to increase in the reactant. So what you will do? 3 Fe plus H2O. You will get it as next step. Fe3O4 plus H2. So here in the reactant, I made iron 3. But hydrogen and oxygen have kept the same thing. Here I have not changed anything in the product. I will write it as it is. Here it is 1. Okay, I have written element. This is 1. Here also 1. Now, iron is balanced, but oxygen it is not balanced, right? So what we will do? Oxygen here it is 1, here it is 4. So I have to increase the oxygen. So to increase the oxygen, what I have to do? I have to put it as 4H2. So I'll get 3Fe plus 4H2O. will get Fe3O4 plus H2. Here in the reactant iron I have not changed. Hydrogen now it will become 4 into 2. It is 8. And oxygen it is 4. Whereas here iron 3, oxygen it is 4 and hydrogen 2. So I have to increase the hydrogen here. So again 3Fe plus 4H2O will get Fe3O4. Here it is 8, right? So I will make it as 4H2. So it is now 3, here 8, and this is 4. Now here it is 3, oxygen 4, and hydrogen 8. So it is balanced.
Is it compulsory like the table in the exam?
Will not get confused. That is the only reason.
We don't write it also.
Yeah. Depending on the marks there. If it is 1 mark not required, sometimes for 1 mark also they will ask as a sub question, then not required. 2 marks, write. Okay. Write down. And how to count here? 4 into 2, it is 8, not 6. You should not add that. Because 4 molecules of water is there, so it is 4 into 2, 8. And after balancing, if you know the states of that, write that also. Okay. So here it is solid, this is liquid, right? So you'll get it as Fe3O4. So this is also solid plus 4H2, this is a gas. If you know the states of that also, write it. Sometimes they ask in the exam, write the balanced equation and which states like that. Then you have to do that, then only they will give marks. Then now try to balance this equation. Third one, HNO3 plus calcium, this is nitric acid, plus calcium hydroxide. It combines with calcium nitrate plus the water. Balance this. First, write the table and do. First, practice well. Then, without table, you can try. Okay. Just write in the reactants what and all elements is there, how many atoms are there in each. Then in the product also, how many are there. So where less is there, you keep on adding and try to balance.
NO3 is considered only one. NO3 is considered.
No.
It's not. So you take nitrogen and oxygen.
It's in separate only. So in the reactants, we have hydrogen, nitrogen, calcium, hydrogen. You have hydrogen here, nitrogen, calcium, and oxygen. In the product also same way, hydrogen, nitrogen, calcium, oxygen.
And it reactants are written hydrogen peroxide.
This is oxygen. hydrogen, nitrogen, calcium and oxygen. So how many hydrogen is there in the reactant? 3. This is 1 here. Here you have 2. So 2 plus 1, 3 are there. Nitrogen, 1. Calcium, 1. Oxygen, oxygen how many are there? 5. Here it is 2. 2 plus 3, it is 5. Here you have 1 calcium, 2 nitrogen, okay, and hydrogen it is 2. And oxygen 3 into 2, 6 here. So we have to multiply 3 into 2, 6, 6 plus 1, 7. Hydrogen it is 2 here, 2 into H, 2 plus 2 here. So it is 4. And calcium only 1. What about oxygen? 2 into 3, 6. And 2 here, so it is 8. It is 8. Okay. Now, what and all is balanced here? Nitrogen is balanced. Okay, calcium is balanced. Main thing is hydrogen and oxygen you have to balance. Here it is 7 and here it is 8. Correct? And here it is 2. So here it is 4. So what I can do here? 2HNO3 plus calcium hydroxide. I will get CaNO3 twice. I will change here because I want to change only hydrogen and oxygen. No. So if I put it as 2H2O, what you will get? Reactant I have not changed anything. I will keep it as it is. And here calcium also same, nitrogen also same. Only oxygen I have changed. Oxygen and hydrogen. Oxygen 3 into 2 is 6 and 2 here. So it is 8. Correct? So it will be 8. And what about hydrogen? 2 into 2, 4. So it is 4. Now it is balanced. Okay. Whenever you want to increase, you have to increase the whole molecule itself. That is 2 times HNO3 like that. Okay. Then there will be changes in hydrogen and oxygen also. Then that also you have to write what and all we will get here. Then try to balance it. Okay. Done. Next one. NaOH plus H2SO4. We will get Na2SO4 plus H2. Sodium, sulfur, hydrogen, oxygen. In the product, you have sodium, sulfur, hydrogen, oxygen. You have 1 sodium, 1 sulfur, hydrogen. How many are there? 1 here, 2 here. 1 plus 2, 3. And oxygen 4 plus 1, 5. Here you have 2 sodium, 1 sulfur, 4 plus 1, 5 oxygen, 2 hydrogen. Okay. So first step, what I have to do? Sharada, what I have to do? I have to increase it because sodium here it is 2, it is 1. So what you will get? Step 1, 2 NaOH plus H2SO4. You will get Na2SO4 plus H2. Here product side I have not increased anything. I will write it as it is. Here 2 sodium in the reactant, 1 sulfur. How many oxygen? 2 here. Here 4. 4 plus 2, 6. What about hydrogen? 2. 2 plus 2, 4. Sodium and sulfur is balanced. I have to like hydrogen, oxygen have to change. Here it is less, it is more in the reactant. So I will increase here. Okay. Here 4 is the hydrogen, right? I can make it as 2H2O. What you will get? Reactant side I have not changed anything. In the product it is 2 sodium, 1 sulfur, hydrogen 2 into 2, 4. What about oxygen? 4 here, here it is 2. 4 plus 2, 6. It is balanced. Balance this equation. NaCl plus AgNO3. We will get AgCl plus NaNO. Many times one question related to this balancing will come in the exam. Okay.
Is it already balanced?
Correct. It is already balanced. Sodium, chlorine, silver, nitrogen and oxygen is there. Same in the rear product. Yeah, it is already balanced. Same thing it is. Sodium 1, chlorine 1, silver 1, nitrogen 3. Here oxygen 3. Here also sodium 1, chlorine 1, silver 1, nitrogen 1. It is 3. It is balanced. Okay. Try this as a homework. Write down this. BaCl2 plus H2SO4. Okay. What you will get? BaSO4 plus HCl. This is not balanced. Balance it again.
No, shouldn't C be capital?
Huh?
For Cl. For BaCl2.
Yeah. Okay. You can, if you want, you can write little bit bigger one. That's it. C capital only. Just write bigger one. Like this. Okay. Then. Okay. Then. We'll complete the session. Okay. Tomorrow we'll continue.